On 12 August, many people will see a deep bite taken from the sun and call it almost total. It is not. At 99% coverage, the moon has hidden nearly all of the sun's surface, yet the light around you can still be about 1000 lux, an overcast day, plainly daylight. When the last bright sliver disappears in true totality, the light can fall to about 5 lux, more like twilight. The last 1% does not finish the same experience. It changes the category of the event. That is why percentage alone can mislead. A partial eclipse is not a damaged total eclipse. The uncovered photosphere still dominates the sky, hides the corona, and keeps the safety rule in force. If any bright part of the sun remains, look only through a proper solar viewer or eclipse glasses. Ordinary sunglasses are not enough. The unaided eye exception exists only during true totality, inside the narrow path where the sun is completely covered. The question for 12 August is not simply, how much will I get? It is, which shadow will reach me? The United Kingdom will see a partial solar eclipse on 12th August. The greatest coverage is in the southwest, but no point in the UK lies in the path of totality. Exact coverage and timing change from town to town because the moon's shadow is moving across a curved Earth. A percentage measures the area of the sun covered. It does not measure how close you are to totality. The total phase belongs to a much narrower route. Greenland, Iceland, the Atlantic, northern Spain, a small corner of Portugal, and Russia. That is not a better partial eclipse. It is the place where the moon's darkest shadow reaches the ground. This is still worth watching from a partial eclipse location. A safe solar filter lets you see the moon's edge advance across the sun, a real, geometric event happening in daylight, but it will not reveal the corona or turn day to twilight, however high the percentage becomes. Use an official local timing source for your exact location, and check the weather on the day. An eclipse is a global alignment, but the view is local. The moon's shadow is not one clean black cone, because the sun is not a point of light. It is a disk. Different rays can slip past the moon in different ways. The outer part of the shadow is the penumbra. Stand there and the moon hides part of the sun, but direct sunlight remains. That is a partial eclipse. Inside it lies the umbra, the small central region where the moon covers the whole bright face of the sun. That is totality. Only there can the corona become visible. This is why the 99% question has a hard answer. The penumbra can give you a profound partial eclipse, but it cannot become totality by degree. The umbra is a different shadow, so an eclipse map is not a colored weather forecast. It is a diagram of what light can reach your particular piece of Earth. New moon happens every 29.5 days, yet solar eclipses do not. The moon's orbit is tilted by about 5.145 degrees to the ecliptic, the plane of Earth's journey around the sun. Most new moons therefore pass a little above or below the sun as seen from Earth. The tilted orbit crosses the ecliptic at 2 points called nodes. A solar eclipse needs new moon to arrive near one of them, the right order, sun, moon, Earth, and the right height. That is the whole monthly mystery. New moon is necessary. A nearby node is the extra condition that usually fails. Even an eclipse season does not guarantee totality for any particular place. The alignment becomes more demanding at every step. First, the moon must be new. Second, that new moon must occur near a node. Third, its center must pass close enough to the sun's center in our sky for the darkest part of its shadow to reach Earth. A near miss gives a partial eclipse. Fourth, if totality is possible, you still have to be standing inside the path made by that dark shadow. The path of totality is the moving trace of the umbra on Earth's surface. Stand outside it, even close to its edge, and you have a partial eclipse. Stand inside it, and the bright solar disk is fully covered for a brief time. Earth turns beneath the shadow while the moon advances in its orbit. The path on a map is a precision alignment in space, drawn across a spinning world. There is one more condition. The moon must look large enough to cover the sun. The familiar version says the sun is 400 times wider than the moon and 400 times farther away. It is memorable, but not quite true. The diameter ratio is about 400.8 to 1, the distance ratio about 389.2 to 1. That creates a near match, not an exact one. At the moon's average distance, it appears about 0.518 degrees wide in our sky. The sun appears about 0.533 degrees wide. On average, the moon is slightly too small to cover it. The moon's orbit is an ellipse. Near perigee, it looks large enough for an aligned moon to cover the sun. Totality is possible. Near apogee, it cannot. The same central alignment leaves a brilliant ring around the moon. The coincidence is a margin. It works sometimes, fails often, and makes the difference between darkness and direct sunlight by a change in apparent size too small to notice on an ordinary night. That gives solar eclipses three principal forms. In a partial eclipse, the moon covers only part of the sun. You are in the penumbra, or the central alignment has missed by too much for the umbra to reach Earth. In a total eclipse, the moon is large enough and aligned closely enough to cover the sun's bright face. You are inside the umbra. Only then does the corona emerge around the black silhouette of the moon. In an annular eclipse, the moon passes centrally in front of the sun but is too small in apparent size to cover it. A ring of sunlight remains. It is beautiful, but it is not totality. Direct sunlight is visible throughout. Partial and annular eclipses always require proper solar protection for direct viewing. A total eclipse requires it throughout the partial phases before and after totality. If you can see any bright part of the sun, your eyes need a safe solar filter. The photographs people remember come from the instant direct sunlight is removed. The corona is always there, the sun's tenuous outer atmosphere extending far beyond the bright disk. In ordinary daylight, it is drowned by the photosphere. During totality, the moon acts as a perfectly placed occulting mask, and the corona becomes visible around it. Near the beginning and end of totality, sunlight can stream through valleys along the moon's rugged edge. Those points of light are Baily's beads. When one bright point remains beside the beginning of the corona, it can make the diamond ring effect. They are the last and first rays of the sun negotiating the moon's uneven horizon. They are also a safety cue. A diamond ring means direct sunlight is visible or about to be visible. Protection belongs back on immediately. The eclipse has not made a new object appear. It has removed the glare that normally makes us unable to see the sun's outer atmosphere. The corona makes totality feel immense. The territory that receives it is not. The moon's darkest shadow draws a narrow path over Earth. Earth turns beneath it while the moon moves in its orbit, so totality is not a country-wide condition or a number on a map. It is a moving place. The broad penumbra can cross whole regions. The umbra runs as a much thinner ribbon through it. A location can be close to that ribbon, even see 99% of the sun covered, and still remain outside the shadow that removes the final bright sliver. That is what the path of totality means, not the places with the best view, but the places with a different physical view. The map is a record of an alignment in space being drawn across a rotating world. For this eclipse, 4 questions need 4 different answers. Where is totality? The narrow central path on the map. What percentage of the sun will be covered where I live? A local calculation, not a national headline. When should I look? A local contact time. Will I actually see it? A weather question on the day. Keeping those separate prevents the common disappointment. A high percentage can be a beautiful partial eclipse, but it does not promise the dark sky or corona of totality. A place on the totality path can still lose the view to cloud, and clear skies do not make a partial eclipse safe to view without a filter. The map tells you the geometry. Your local forecast tells you whether the geometry will be visible. Proper solar protection tells you how to watch it. A partial eclipse is worth seeing safely for what it is. A solar eclipse asks for one piece of discipline. Do not improvise with your eyes. Use eclipse glasses or a handheld solar viewer made for direct solar viewing and in good condition. Inspect it first. If it is torn, scratched, punctured, or otherwise damaged, do not use it. Put it on before looking up. When you are finished looking, turn away before taking it off. Ordinary sunglasses are not safe. Neither is looking through an unfiltered phone camera, binoculars, telescope, or camera lens. Optical equipment concentrates sunlight. A solar filter for a telescope or camera belongs securely over the front of the instrument, not between the instrument and your eye. If you are outside the path of totality, keep the protection on for the entire eclipse. If you are in the path, remove it only once the moon completely covers the sun's bright face, and put it straight back on the moment any bright edge returns. Totality is spectacular because it is exact. Treat the safety rule with the same exactness. The near match between sun and moon will not last forever. Laser measurements made with retroreflectors left on the moon show that it is moving away from Earth by about 3.8 centimeters each year. That is tiny in a lifetime, but it changes the angular size of the moon. Far in the future, on the scale of hundreds of millions of years, the moon will be too small in our sky for total solar eclipses. So totality is not the permanent state of this system. It is a temporary margin in a long celestial rearrangement. On 12th August, the margin will hold. A new moon will arrive near a node. Its orbit and apparent size will allow its umbra to meet Earth. Earth will turn beneath that shadow, carrying a narrow sequence of places into the one view where the sun's bright face vanishes and its atmosphere appears. The sun will not go out, the moon will not grow. For a few minutes, in the right place, a moving shadow will make the invisible visible. Then the line will slip apart, the bright disk will return, and the coincidence will continue on its slow way out.